All right, so let's get started. Solving exponential equations with logarithms. Typically, when we solve exponential equations, we are always able to find a common base, like in the example you guys see up here at the board. Everybody look up here for me. What base did we find in common? 3. We said 3 to the power of x equals 27. We can make both of those have a base of 3. Cross off the bases, and since the bases are equal to each other, therefore the exponents are equal to each other, and x equals 3. That's how we've always done it in the past. Today we're going to look at it when that's not able to happen. So, what if we find, what if we cannot find a common base, like in the example that you see over here? We have 7 to the power of x equals 50. Do you know a way to make 50 have a base of 7? Do you know what? Yeah, it's going to have decimals. That's what we're going to look at today. So 7 to the power of 2 is 49. That's pretty close to 50, so I'm guessing it's somewhere around 2. But we're not exactly quite sure what it is without knowing how to do it with logarithms, and that's what we're going to talk about today. So if you look up here, here are the steps to how to do it, and I want you guys to write down these steps right across from this example. So I'll have you guys write down everything on this page for me, and I'll give you a few minutes to do that, and then we'll talk about it. So take a minute or two to write down the problem, and then write down the steps. I will insert some arrows so you guys can see which steps correspond to which part of the problem, and then I'll explain it. So, when we are trying to solve an exponential equation and we're not able to figure out the logarithmic base that would be the same, like in this case, these are the steps we would take. It says, number 1, make sure the expression with the exponent is isolated. So the arrow that corresponds to that is this. Notice that we have an expression here, 7 to the power of x, and that's isolated all by itself on that side of the equation. That's exactly what we want. We want it to be isolated all by itself. There will be examples today where you see a number being multiplied times that exponential expression. Or maybe you see a number being added or subtracted. You want to get rid of that first before you do the rest of these steps, just like we did with logarithms. You want to isolate the logarithmic expression first. After you're done with that and you have successfully isolated the exponential expression, the next step is to, and I have it in quotes, take the log of both sides. So typically what we've been doing in the past is we've gotten rid of the log on both sides, right? We use the equality property and we say, oh, there's a log on the left and there's a log on the right. Let's cross them both off so that we can set what they're equal to each other. Their quantities equal to each other. In this case, we're using the reverse of that. We're undoing the equality property and bringing logarithms back so that we can get that x by itself. Because typically the x has been in the quantity instead of in the exponent, but now it's in the exponent. So we take the log of both sides to undo that equality property. From there, on step 3, we use the reverse power property. So typically we take coefficients and put them up as exponents. This is taking the exponent, which is x in this case, and it's bringing it back down so it's on the same level as the logarithm. Now it's a coefficient. Again, kind of undoing these properties of logarithms that we've been using so that we can get that x all by itself. We want to get it out of the exponent so that we're allowed to get it by itself. And last but not least, the 4th step is to isolate or solve for x. And the way we do that is just to get it by itself. In this case, it required a little division. So we divided by log of 7 on both sides. And then this, although it probably looks pretty scary, we're just going to put into our calculator. When you put that into your calculator, and I'll teach you guys how to do that today, you should get 2.010. All right, we're ready for our example? I'm going to do one with you, and then you're going to do one on your own. And you guys are going to use your calculators to come up with a decimal answer for what the exponent would have been. All right, here we go. We're going to do number 1 on the left-hand side together. If you guys could write number 1 down, that would be great. And as we do number 1 together, we're going to talk about all those properties and steps. So, step 1 was to isolate the exponential expression. So if here's my equation, and I circle my exponential equation, do you guys see anything else over there with the exponential expression that's bothering it? Anything being multiplied? Anything being added to it on that side of the equation? No, it's good. So first step is already done. We have nothing to isolate. That's great. Step 2 says to take the log of both sides. So I want you guys to rewrite this problem again, but I want you to write a logarithm in front of both sides. So we're going to write log of 20, n, 20 to the power of n, equals log 79. And remember, anytime you have log that has no base, what's that base that's invisible down there? 10. That's called the common logarithm. That's log base 10. Our calculators can do log base 10, which is why I chose that. It doesn't really do much others unless you kind of finagle it to do so. So we'll keep it easy and keep it base 10. All right, that was step 2. Step 3, take the reverse power property. I want you guys to bring the n down front. So circle that n and bring it back down front of the logarithm with the reverse power property so we can get it out of the exponent. I don't want it in the exponent. And we'll rewrite it one more time. N times log of 20 is equal to log of 79. And last but not least, the fourth step was to solve for or isolate the x. Or in this case, I guess it's an n, but that's okay. It's the same thing. It's just a variable. So if we're going to isolate that n and get n all by itself, what do we need to get rid of on that side of the equation? I need to get rid of this log base 20, or log of 20, I'm sorry. Is it being added, subtracted, multiplied, divided? It's being multiplied. What's the opposite of multiplication? Division. So let's divide log of 20 on both sides. So we'll divide by log of 20 here and divide by log of 20 here. Over here on the left, log of 20 divided by log of 20 will be 1. We get n equals log of 79 divided by log of 20. Remember, this is not one of our properties, so don't confuse this with thinking this is the same thing as 79 divided by 20. Don't cancel out the logarithms. At this point, we're just going to put it in our calculators. So, everybody get out your calculators. You can round it to the thousandths place, which is 3 decimals. All right, and I'm going to do it with you guys on my calculator as well so that you guys can see how it's done up here. So we have log of 79 divided by log of 20. Let me just pull up my calculator. Alright, so on my calculator, there's a lot more buttons maybe than on your calculator. Somewhere on your calculator you should have a button that looks like this and says log. You probably also see one that says ln. Mine's right underneath it, but don't use that one. That's a different base than log. So we're going to use log right here. And okay, so we're going to push log of 79. So I'm going to push, on my calculator, I go log first and then 79 divided by log of, I forgot the other number. What was the other number? 20 divided by log of 20. On my calculator, that's how I enter it. So when I push enter, I get 1.458. That's the tens, hundreds, thousands place. If I round it, I get 1.459. So that would be the correct answer. Make sure you got 1.459 on your calculator. Some of your calculators might be different. On mine, I push log and then 79. On some of yours, it might be the opposite. Maybe you push 79 and then log, and it evaluates for you immediately. I know on the iPhone calculator, it definitely does that. You do it in the opposite order. So mess around with it for just a minute until you're able to get it to say 1.459, and then we'll move on to our next example together. Alright, so here's the second example. You guys see number 2 up here on the board. It says 12 to the power of x equals 81. I'm going to give you guys about 2 minutes. I want you guys to solve that equation on your own. I'm going to come around and check it on your paper, and I'm going to take a picture of somebody's work and put it up here on the board. If you're still not able to get 1.459 on your calculator from example 1, as I walk around, please just call me over and I will come help you figure out how to make your calculator do that. Alright, so here's that second example, and this is what I saw when I was coming around for you guys' papers. You guys can go ahead and check up here on the board, make sure you got what they got. So this is a perfect answer, and from what I saw, many of you guys had the same one, which is awesome. We took the log of both sides because 12 to the power of x was already isolated. We used the reverse power rule to bring that x down front so we could get it by itself. We divided by log of 12 on both sides, and we put that into our calculator. Log of 81 divided by log of 12 is 1.768. So far, so good. Any questions that you guys have so far for me before we move on to ones that maybe are a little bit harder, maybe 1 step harder or 2 steps harder? All right, then let's try one of those. Perfect. Do me a favor and write down number 5. We're going to do number 5 together. Now, when I say 1 step harder or 2 steps harder, typically you guys might be like, oh my gosh, we've been doing so easy problems and now they're going to get so much harder. But that's not true. Even though we're working with exponential equations, they do not get exponentially harder. There's only one little additional step, and it comes in the very, very end of our problem. When we're ready to solve for x, we have one little extra thing that's bothering the x up there. Bless you. And we'll have to deal with that. So I'll teach you guys how to deal with that. So in this one, number 5, can you tell me what else is kind of different? Besides, I know the numbers are different, but what else is kind of different about this problem than the other one? Yeah, the exponent now has something else happening to it. It has a -4. When we go to solve for x at the end of our problem, when we get an answer for the division of the logarithms, we'll just have to add that 4 to the other side. And we'll just say that that's part of our answer as well. And it won't change anything. It'll just make our decimal being added by 4. So let's do this one together. Step 1 says to isolate the isolate the exponential part of the equation, the exponential expression. It's already isolated. I know there's that -4 up there in the top, but it's not bothering the expression. It's actually in the expression. So we don't need to worry about that -4 quite yet. Step 2 is to take the log of both sides. So on your paper as well, please rewrite this expression, and let's write log in front of both sides. Log of 5 to the power of x minus 4 equals log of 32. Step 3, get rid of that exponent. Let's bring that exponent down front using the reverse power rule just like we did before. This time we're going to bring x minus 4 down all together. Let's take the whole thing down front. And let's rewrite this together. So we have x minus 4 times log of 5 equals log of 32. Now again, I know that -4 is in there. We're going to deal with that in just a minute. Let's get rid of that logarithm first, and then our last step will be to add 4 over to the other side. So to get rid of that logarithm, let's divide it just like we did previously. Divided by log of 5. Divided by log of 5. And let's get a decimal for that now, because sometimes I think it's easier to work with decimals rather than keeping it in terms of logs. So why don't you go ahead and put that into your calculator right now, and tell me what you get when you divide log of 32 divided by log of 5. Perfect. All right, I also got 2.153. And now the last thing we need to worry about is isolating x completely. So now is where we get to deal with that -4. The -4 needs to go away. How do we get rid of that -4? Add it to the other side. So if we add 4 to both sides, we get x is equal to, if you need to do that in your calculator, go for it. If you can do it in your head, that's awesome. 2 plus 4 would be 6. So this is 6.153. Final answer. So again, sometimes there will be something up there in the exponent bothering the x. Just get rid of it at the very end. You guys can see on number 6, there is also something bothering the x up there. And again, wait till the very end and you can get rid of it in the last step, because that's the last part of isolating x, is getting rid of that. Take a minute or two and try example 6 on your own. I'll take a picture of somebody's paper and put it up here on the board. So we have a solution up here on the board. You can kind of see it jumps down to the second step. So we took the log of both sides since our exponential expression was already isolated. We brought the -10x down front since that's the reverse power rule. Divided by log of 18 and got 1.127. And then divided by -10 and got negative. It's kind of hard to see, so I'll write it in as well. This is equals a negative. There was a negative sign in there. Equals a negative 0.112 if you didn't round it, or 0.113 if you did round it. So either of those are fine answers with me. If you put 0.112 or negative 0.113, I'd be okay with either of those. All right, so far so good? Okay. Let's try another one where we haven't utilized step 1 yet. Let's actually utilize step 1. We need to learn how to also isolate our logarithm. So we're going to go ahead and do that now. Does everybody have this copied down? We can move on? All right, perfect. So here's our last 2 examples for today before I give you guys your assignment. Write these ones down. We're going to do number 7 together. You guys can do number 8 on your own. Now, step 1 we haven't talked about yet. We've gotten to skip over step 1 every single time because it's been done for us. In this example, it's not done for us anymore. So if we look at our equation, here's my balancing act for my equation. If I look at the exponential part, it's a base to an exponent. So 2 to the power of m is my exponential expression. What's bothering the 2 to the power of m on the same side of the equation? The -5. I need to be able to get rid of that -5 to isolate my exponential expression. Now, right now, -5 is being what to 2m? Multiply. The opposite of multiplication is division. Let's divide by -5 on both sides. When I do that, you are able to, let's get rid of that. We have 2 to the power of m equals, let's put that as a decimal now. Again, for the same reason, I think with you guys and your calculators, you'll probably feel a little bit more comfortable if you keep things in terms of decimals when we're working with logarithms, so we don't have anything fractional like this. So what is negative 6 divided by negative 5 when you put that into a calculator? 1.2, beautiful. Positive 1.2. And now we have it looking like what we had it looking like before. So let's go ahead and finish this out the same way we were finishing it out previously. We did step 1, which was to isolate the exponential expression. Step 2, take the log of both sides. So this is log of 2m is equal to log of 1.2. Step 3, use the reverse power property to bring down the exponent in front so we can solve for that m by itself. We need it out of the exponent. When we bring it down front, we get m times log of 2 equals log of 1.2. And last but not least, step 4 says to isolate that variable. Let's get m all by itself. Let's divide by log of 2 on both sides. Divided by log of 2. So m is equal to, you put that into your calculator, log of 1.2 divided by log of 2. Log of 1.2 divided by log of 2. I got 0.263. Did you guys get 0.263? 0.263. All right, your turn. Take a minute or two. Do number 8. That's our last one for today. Okay, so our last one. We need to get rid of that 6 first, so we add it to both sides because it's being subtracted. That gives us 27. When you take the log of both sides, you get log of 19 equals log of 27. Bring the n down front, divide by that log of 19, and we get n equals 1.119. Beautiful. Are there any other questions before I give you guys your assignment for this evening? All right, let's get started then.